What'd you get? Did it come out even close?
I got negative 0.2068.
Okay, well at least we're kind of on the same.
Yeah,
Because I think their actual answer was close to that.
it's positive 0.209.
Oh, just kidding. I think they just forgot the negative,
Yeah,
which would get us close, but I still didn't get their exact answer. So I don't know if they just use Excel or something. I don't know.
I'm not sure either.
Because I know the rounding can be different from
Right.
program to program. But as long as we're close, I think we'll be okay. Um, those are my biggest questions. Did you have any other questions?
No, not really.
All
Okay.
right. Well, I don't know what's happened with Mackenzie or Darby, but you just want to take this quiz?
Yeah, let's do it.
All right.
I can read number 3. It says, the hypothesis test consists of two hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo? That's the null hypothesis.
Agreed. Which hypothesis involves equal sign? That's also the null hypothesis, isn't it?
Is it? I thought it was the alternative.
Oh, great. Um, because I thought the alternative hypothesis is always going to be it's not equal to, or it's greater than, or it's less than. But I didn't remember the alternative ever being equal to.
You're right. Okay, sorry.
You're good.
You're right. Okay. The p-value is the probability of obtaining a sample statistic at least as extreme as one that was actually observed. Use the information to question 5. Okay. When computing the probability, which hypothesis do you assume to be true?
It's a null.
No.
Basically, the last question is this 4. It's the same as 4.
Yeah.
6. Which of the following represents the alternative hypothesis for two-tailed test? That's the not equals one.
Do the following represents the alternative hypothesis for the left-tailed? Isn't that where the mean is greater than, isn't it?
Uh,
Trying to remember.
the notes. I don't remember. I was thinking it was because of the. I don't know. I'm not gonna try to guess.
Okay, so left-tailed is when the number is greater.
When it's greater, so u is greater than 10.
Oh wait. Okay.
See, don't lie to me.
Okay.
Joel.
So I'm just going to make this simple. Oh, when it's left-tailed, the Pac-Man is eating the 10.
if it's left-tailed, the Pac-Man.
It's eating like the number, basically, not the mean.
So, so the 1 point is pointing towards the U, and the 2 points are pointing towards the 10.
Yes.
Okay. That makes more sense to me.
Okay, sorry.
It's all good.
And then right-tailed is the 1 point is pointing towards the 10, and the 2 is pointing towards the mean.
Got it. Okay. Number 9 says the outcome of a hypothesis. Oh, well, this is for 9 and 10. The outcome of hypothesis test is determined by comparing the p-value to the level of significance, or that symbol. Use the information for questions 9 through 10. Which relationship would result in failing to reject the null hypothesis? Crap.
Okay, so the outcome is determined p-value to the level. The relationship result in failing to reject.
I think its p-value is greater than x. Because the last night in the homework, when, like the very, very last question or second to last question, it makes you compare your p-value to the level of significance. And ours was 0.836-ish, which is greater than 0.05, and so it failed to reject the null hypothesis.
Right.
Because it has to be, the chance of it happening has to be so tiny. It has to be less than the statistical significance. The statistical significance for you to reject it.
Okay, right. And then would result in rejecting, that's where alpha is greater.
No, it's less than.
Alpha is less than, or the p-value is less than?
The p-value is less than alpha.
So confused.
Because on our homework last night, the p-value was greater than alpha. 0.836 was greater than 0.05. The Pac-Man was eating the p-value.
For number 9.
For 9.
Okay, and then for number 10, the Pac-Man is eating alpha.
Right.
Okay, yeah, got it.
Oh, man.
That's how I learned when I was little, so.
Hey, whatever works. Okay.
An insurance company is reviewing the current policy rates. When originally setting the rates, they believe the average claim amount was $1,500. They are concerned that the true mean is actually higher. Use the information for questions 11 and 12. So which of the following would be appropriate alternative hypothesis? So, the average claim amount is greater than 1,500.
Right.
Right.
And then which of the following would be the appropriate null hypothesis? Would be the average claim amount is equal to $1,500?
Yep. So the insurance company randomly selects n equals 40 claims and calculates a sample mean of 1,650. Use this information. The insurance company assumes the distribution of the sample mean is normal Is this a good assumption?
I think we have to do math.
Do we have to do math yet? Well, they assume that the distribution is normal.
Oh,
I would say yes.
it's greater than 30, so yes.
Yes?
Because of the
And then what theorem or law justifies the answer in the previous question? That's the not the central limit, but more likely.
why do I feel like they ask us that all the time, and I always second guess myself.
Yeah, because like if the sample size is large, the sample mean will probably be approximately normally distributed.
Yeah.
Be this central limit.
Yep.
Which of the following is the test statistic as defined in this lesson? That'd be the x at the line over.
It is.
No?
I don't know. Hold on.
Oh no, you're good.
I was thinking it was Z.
Oh, it could be Z. Okay, you're right. I think you're right. I'll go with your answer.
Yeah, I just found it in the homework, so.
Okay. Cool. Okay.
Says the historical mean of sales receipts at a grocery store is $150 with a standard deviation of $40. Manager suspects that the average has decreased. She sets up a hypothesis test with the following. HOU equals $150. HAU is less than $150. She will use a level of significance of. Did you say that's called alpha? I need to learn these. Or is that theta?
That's alpha.
Okay. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 soda sheets from her store and computes X bar equals $144. What is the z-score associated with this test? Let me do some math.
Yay.
I'm getting negative 0.9.
Negative 0.9. That's what I got.
Okay. So then the probability I'm getting is 0.184.
How'd you figure that out?
I plugged it into the applet.
Stupid computer. Sorry, my computer's freezing.
No worries.
you got 8 or 0.816?
Nope.
No? What'd you get?
I got 0.184.
Oh, okay. Yeah, I just had the wrong part highlighted.
Okay. And then 18 says, what inference would you make about the null hypothesis for this problem? Because it's greater than the Pac-Man's eating 0.184, then you would fail to reject the null hypothesis.
There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null is true? That'd be a type 1.
Yeah. Agreed. A researcher that decided that instead of using a level significance of 0.05, he'll use a level significance of 0.01. Which of the following will be true? The probability of type error 1 will increase? No. The probability of type 2 will increase? No. The probability that the null hypothesis is true will decrease? I don't know which of those is right. I didn't think it was either the first two because I thought the probability of an error is always decreased when you increase it to the level of significance. But I could be wrong.
Yeah. I would go with that the probability of the null hypothesis true will decrease.
Okay. But wouldn't it be less likely that it's going to be? Isn't it going to be more likely that the null hypothesis is true because there's less of a chance that you're actually going to be able to prove it wrong?
That's true.
Maybe that only leaves the last one. I mean, it would be more valid because of.
That's true.
I guess. I'm going to go with the last one, but I do whatever you want.
Okay. Well,
I don't remember how to do 21. I don't remember that ever being in the homework.
if alpha compute the probability of committing. I think it's just the same.
Is it?
Yeah, because alpha is involved with,
You're right. I just found it in the homework.
so it'd just be 0.05.
Yeah, I guess.
Sounds too easy, but
All right, I'm gonna submit this sucker. I'm scared.
two. This one. Probably, wow, okay.
Sorry.
No, you're good. We weren't sure, so it's not a big deal. We were both wrong, kind of thing, so you're good. We did good otherwise, though.
The probability of a type 2 error. I don't understand that. I wonder why.
Yeah, I'm not sure either. I was trying to read it in the book, but I didn't see anything.
Let's see. A type 2 error is when. Type 2 error is when you say that it's true, but in reality it's false.
When the alternative is true.
But you say that it's. You say that the null hypothesis is true.
But in reality, it's not true.
Right. Huh.
Well, it might be because he's saying that the probability because it's lower, it's more likely to be true. In reality, it's false. I don't know. You would know that, actually.
Yes. I don't know. I think I'll try to figure it out when I'm less tired.
Yeah, probably. Usually that helps.
Oh man. Are you getting sick? You sound like you're getting sick.
Yeah, I think I am.
I'm sorry.
No, it's all good. Just, it just sucks. I'm like super tired too, but it's good.
Did you get up to work out again this morning?
I did not.
Oh.
Yeah, I didn't go to bed till like it was like almost 1, and I fell asleep. I think.
Oh.
Yeah, I just couldn't sleep, so I was like, I'm not going.
Well, that sucks.
Yeah, but it's good.
If we decide we don't want to do these Thursday mornings so early, it won't really hurt my feelings. So.
Yeah, it won't hurt my neighbor because I have like I have the nights open. I just don't know about like everyone else, but.
I have institute from 7 until 8:30, but other than that, I can do any time before or after. So.
Okay. Cool. Yeah, I'm done at 4 on Thursdays, so on Tuesdays and Thursdays, so anytime.
Okay. Well, we can maybe figure it out next Tuesday, but if it's just gonna be you and me, we ought to do it.
We just ought to make it later.
Yeah.
Yeah. For sure.
All right. Well, thanks. I will see you Tuesday at 7:45.
Yep. Sounds good.
All right. Talk to you later.
See ya.